Okay, great. Thanks, everybody. So I thought we'd do a journal club today. I've circulated 2 articles that we could talk a lot about how to analyze unstructured text data, but I think a useful place to start is also thinking about assessments of the quality of unstructured text data. And there's more and more literature that's coming out about how you do those assessments and what impact they may have on the analyses that are done subsequently. And this is work that Marcello and I have been doing. So Marcello's a master's student in the Department of Community Health Sciences. And we have been looking very specifically at the literature around the quality of unstructured text data and ways that you can possibly measure that. So the papers that I've chosen are, I think, some useful starting points for discussion. They're certainly not without their flaws, but they're nice examples of some of the work that's coming out now around quality of unstructured text data. And so we'll start with the Kiefer article and then go on to the Alnadran article. And just a reminder, when we're talking about unstructured text data, there are these big categories that are used. We can talk about structured data that comes in quantitative form from databases, to semi-structured, and then to unstructured data, and a variety of forms of that. Will focus specifically on text data. And I thought a useful place to start is when we think about the quality of structured data. This is a framework that is used at the Manitoba Centre for Health Policy, and some of the work that I was involved in a few years ago. And so we recognize that data quality is, first of all, a multidimensional construct. And when we think about routinely collected data, assessments of quality are an important step prior to using the data in any kind of research or surveillance project. And at the Manitoba Centre for Health Policy, as at other centers that do linkage of various kinds of routinely collected data, there are really 2 phases to that. Recognizing that you can, without linkage to really any other data sources, you can do a high-level assessment of data quality. And there are a variety of domains that are represented here, from accuracy to the interpretability of the data that relies on the documentation. And so that can give one perspective. So we can look at the completeness of the data. We can look at things like stability over time, how well we can link the data to other sources. And at the Manitoba Centre for Health Policy, there are a variety of macros that are in place. So routine software that can be implemented to do data quality assessments. And then there's the other piece of it, thinking about a specific research project and the quality of the data for being able to undertake that research project. And what's represented in this data quality framework are 2 different domains that are particularly important when we look at the research level. So accuracy and also reliability of the data. And so what happens when a data quality assessment is done on structured data? Well, if it's less than optimal quality, then there will be consideration of different models or methods to correct for quality deficits. So there are a variety of methodologies that have been proposed to deal with measurement error, things like missing data. If there's selection bias and particular groups may not be represented or underrepresented, there may be opportunities to do some weighting. And then dealing with outliers or extreme values may be another approach as well. So that's what happens in the structured data realm. So what about unstructured text data and the quality of it? So it's recognized in general that before any analysis is done, there'd be a pre-processing stage. So that really is the part where we're doing a data quality assessment. So what is pre-processing? So bringing that unstructured text data into a form that's organized and that could lead it to be analyzable for a specific task. And so some of the tasks and what's represented in the literature, the 2 papers that I assigned for reading, things like language identification, looking at parts of speech and being able to tag those. We often think about feature extraction, so being able to pull out specific information. If it was electronic medical records, for example, it might be information about diagnoses or particular treatments or some sort of measures of behavior of individuals. And another task might be measuring the similarity between different texts. And so Marcello and I have been looking at this, and there are some parallels between what's done with structured data and what is defined as pre-processing, so looking at the quality of unstructured text data. So there are restructuring and organizing approaches that can be used, and then there's also validation. So there can be external validations, just as we do with structured data, and also internal validations. So there might be text from different locations or different sources within a single data set. If we're thinking about electronic medical records, for example, there might be information in two different components of that electronic medical record that represent, that contain unstructured text data. And so there might be some comparisons between those as a way to assess the quality of the information. So there's a lot of parallels there, but also some differences. And Marcello and I have been focusing a lot on these restructuring and reorganizing approaches. And in fact, we've worked on a systematic review where we've looked broadly across a variety of different disciplines at literature that talks about how to pre-process unstructured text data. And so this systematic review that we've been working through extracting information from, when there's discussion about how you would restructure or reorganize the data, these are some of the methodologies that are used. So looking at stop words, these would be words like and or and removing those before actually doing any analysis. Punctuation, things like how you break words into parts would be a component of that. Part of speech tagging is also regarded as a way to do restructuring and reorganizing. It might be a specific task, but it might also be part of that. Looking at word stemming, so taking the roots of words or doing some sort of segmentation, spelling errors, and also abbreviations. So this is what's described in the literature, and from the systematic review that he's been doing, there's 34 articles in it. This is the frequency of the approaches that were mentioned for restructuring and reorganizing unstructured text data in those particular articles. So that's really the context or the background for thinking about quality of unstructured text data and how I wanted to frame the discussion that we'll have today. So the Kiefer article, Cornelia Kiefer has written a few papers about trying to develop indicators of unstructured text data. And really is interested in the extent to which these indicators might be able to predict the quality of text analysis results. And in this particular paper, she talks about two types of text analysis, so doing language identification and also a part of speech tagging. So that's the contribution. And so she divides these text data quality indicators into two groups. Those that are really focused on the data and those that are focused on describing the quality for doing text analysis. And she talks about implementing a number of different modules for doing text analysis and uses those to define 3 different indicators. And she's written other papers on this topic and doesn't limit this particular set because there are other things that may be useful, but starts out with this as kind of a baseline point for thinking about what might be useful indicators of data quality and then how they might be used subsequently to guide analyses. So some of these are quite self-evident in terms of what they be. Others, I thought I'd just talk a little bit about how she defines those. So identifying abbreviations. There's reference in the article to using different external sources in order to be able to do this. And so with the abbreviation, so how do you define an abbreviation? Well, she talks about using the Stanford named entity recognizer and really using a classification method to do this. So with some manually labeled data and some initial data pre-processing, which was done using a natural language processing tool called Core NLP, there was training done and then this conditional random fields approach to try to figure out which were abbreviations and which were not abbreviations in the exemplar data sets that she explored for this data quality indicator assessment. She talks about lexical diversity as another potential data quality measure. So looking at the length of a set of tokens and words in a text divided by all of the tokens and words. So it's other sources have defined lexical diversity as a ratio measure of the number of unique lexical items by the total number of words or lexicons in a sample. And a lexical item could be a single word, it could be part of a word, or a chain of words that forms the basic elements of a language's vocabulary. Okay, and then I haven't gone through the definitions for all of those. You can certainly read the paper for those. So there was those 6 measures looking at the data itself. And then she talks about these indicators that look at really the text analysis module. So the fit of the training data, looking at the similarity between the text data set and some training data set. And so for the example, she was using the Penn tree bank data set. And this is a very large data set that's been annotated. It's huge and it's used as a reference in a number of papers that we've looked at around text data quality. And there are different kinds of annotations. So parts of speech, syntactic, and also semantic skeletons is what they're called. And so she looked at the fit of the data, these different operational text data sets, comparing them to a default, and different tools used in a piece of software called OpenNLP, and then used this cosine similarity measure, which appears in the second paper, and I'll talk about that a little bit later on. Okay. And so Kiefer talks about the confidence of standard processing modules, so calculated for these different classifiers, and ends up producing probability values. Although I thought the paper wasn't all that clear in what these processing modules were that were used in the paper to produce these measures for the text analysis modules. The paper identifies ones coming from the OpenNLP library, like tokenization and part of speech tagging, but I thought the paper was a little unclear around how some of that work was actually done. But these confidence measures are produced for these different modules. And so then Kiefer talks about, so how would you use the indicators? And so she suggests that it might help someone decide on the methods to improve the quality of unstructured text data. So once there are some numeric values that have been calculated for a specific data set, or even for comparisons amongst different data sets, that might be useful in making decisions, for example, about the steps that will be taken in pre-processing. Although the paper is not really clear on this, and Kiefer identifies that another paper is planned to discuss the specific steps that might be taken in the quality improvement process. And so that's in part why I chose the second paper for our discussion, because I thought it was useful in thinking very rigorously about the steps that might be taken if we have some data quality indicators to rely on. Okay. So Kiefer took these 9 indicators of data quality and applied them to very different kinds of data. And so here's her table 2, which describes the source of the data, and they represent, there's tweets, there's the tree bank database that's actually used. It was used as a reference standard, but it's also used to describe these data quality indicators. And she also talks about this industry corpus, which contains some production data. And so there's information too, there's various sizes of the data, and she talks at different points in the paper about thinking in the data quality in relation to size as well, and how size may be helpful in really establishing the reliability of the numbers that are produced with these data quality indicators. Most of the example data sets came from this NLTK platform, which is used for building Python programs to work with human language data. And there are many corpora and different models that are a part of this. And so there's actually some example data sets that are stored within this toolkit, and that was the basis for some of them. The industry data had information on reasons for downtime, and that was from one company in Germany. And so these downtimes in relation to what was going on in production. And she notes that all of the data sets had an accompanying gold standard that was used to calculate an overall accuracy measure. So that was a component of what's included in the results, in addition to these different data quality measures. So in her table 3, she shows for the different measures, or for the different data sets, the results of applying these data quality measures here. So again, there's an overall measure of data quality, and then she looked at 2 different accuracy measures for specific purposes, and then she assigns a numeric value, and mostly in percentages, although some in terms of the average sentence length are or a mean value. So she kind of goes between, and then there's these confidence measures as well, which are expressed in terms of probability. So I thought it could have been improved by putting things on common scales, but anyways, that's for another time perhaps. And so she talks about the variations in data quality that existed, I think I've got a couple of notes here, right? The overall and then the single accuracies, and those accuracies were for the 2 text analysis modules. So there was this language identifier, and then this part of speech tagger from the NLTK open source software. And she also notes that in the industry data sets, there weren't any manual annotations of the parts of speech, so there was no overall accuracy measure that was produced there. Yeah, and then that's just a description of these accuracy measures in terms of proportions. Most of the indicators are reported as percentages, and then the average sentence length. And so Kiefer goes on to describe that there's wide variations. It's helpful to do some comparison across these different data sets. It's not unexpected, perhaps, that when we look at really curated data sets such as TreeBank, that she describes this as having much better quality. So if we look, for example, at the percentage of abbreviations, it's relatively low there compared to some of the other data sets, including the Twitter and the chat, and then lower quality also when we think about these confidence measures. So how she concludes this paper is saying that these suggested data quality indicators give us a way to quantify something that can be challenging to quantify when we think about unstructured text data, and that this might be helpful in figuring how we're going to deal with a particular data set. And of the 9 indicators, they don't require manually labeled data in order to do this. So she cites that also as a benefit of being able to produce quality indicators for unstructured text data, and that we don't want to rely on that, what can be an onerous process, and where very little of our entire environment for unstructured text data, really very little of it is manually labeled. And so if we were to use that as the basis for developing data quality indicators, it would be challenging for us to apply these kinds of indicators in routine practice. as we have done at the Manitoba Centre for Health Policy with our measures of data quality for structured data, it's really beneficial to be able to implement something routinely and have that information in your back pocket, because it often is used to guide what comes next in terms of massaging the data into a format that may be useful for a particular study. Okay, so Kiefer suggested that these can be helpful, and in terms of subsequent text mining, and they're recommended as a starting point that may indicate quality. And for each indicator, there will be strategies in terms of how to improve the quality of the data based on these indicators. So that's a next goal in terms of what she wants to do. So that's the Kiefer paper. I'll just stop there if people have comments or questions, observations that they want to make around that particular paper.
Lisa, if I may, I'll just comment. I appreciate you sort of getting us to look at this, because it's been my own notions of quality tie very tightly to a particular purpose, and this is really an interesting way of sort of bubbling up a level. And I know that I probably need to think more about the way that MCHP has addressed the structured data from that same kind of, in a general way, is this high quality data? It's, you know, when I'm looking at a particular data set, I have a particular analysis in mind, and I evaluate quality through that lens. And this is very different. So thank you.
Yeah, and I think about it in relation to the electronic medical record data. So that's coming into the Manitoba Centre for Health Policy. More and more people are wanting to use, for example, electronic medical record data. And is it useful to think about data quality indicators as that, just as Kiefer says, as that starting point? Think about what might come next. And also, when we think about pre-processing, what exact steps might that involve? Yeah. And that's where the second paper, I think, jumps very nicely into saying, well, you know, do we need to have some standards around how that's done? Do we need to think in a very rigorous and methodical way about what exactly that pre-processing involves?
Yeah.
Yeah, you know.
Okay, any other comments?
Yeah. So I really like Robert's comment there. That's because I was thinking myself, I'm always tending towards applications of things. I'm thinking, you know, well, the application of this for my realm, anytime I want to do any programming task, you immediately Google, and Stack Overflow is like the gold standard for good information. Reddit is the gold standard for useless information. And so to me, all this would be important to establish credibility. And when I think about that, so there's these specific indicators that have been kind of selected here. And in today's world, it seems to me there's a constant tension between trying to explicitly engineer features versus, in deep learning, for instance, you just pile all the data in there and let a network figure out the features on its own. So I would be curious to see a comparison between this approach and, say, going to Stack Overflow, where everything has an upvote or downvote on it, you know, and so try and learn a credibility number by looking at all of Stack Overflow and using the upvotes on the answers as the credibility number. You know, I'd be curious how that kind of approach would compare to this one, which is more engineering of features explicitly.
Yeah, okay, thanks for that, Doug. Okay, anything else before I launch into the second paper? All right, so let's talk then about the Alnadran paper. So this one really then goes into the next step, saying, well, let's look at a very specific pre-processing method. And here the focus is on a particular application. Short text tweets are used in this particular case. And what the Alnadran paper does is compare a based method to a classical approach, what the authors describe as a classical approach for pre-processing of short texts. And that comparison is performed within the context of doing some semantic similarity analysis of these short texts. And so this paper describes this heuristic approach, which is really just an approach to problem solving that uses a very practical method. And so really the Alnadran paper is all about saying, well, but if we go through in a very specific sequence and do pre-processing and think quite methodically about that, how does that compare with what they describe as the classical approach, which might be a bit more ad hoc, which has some of the same steps, but might not be done in a specific sequence, or considering the exact same methodology applied to many data sets. And so this heuristic pre-processing approach that they use in the paper starts with decoding, so just putting it into a particular structured organization and then moving sequentially through these steps. So it's about retreats and taking out URLs because we're dealing with tweets, and then using very specific software to do things like identifying what the tokens are in the data, doing parts of speech tagging, looking at punctuation, for example, thinking about the words and any contractions and doing some standardization. And of course, because what appears in tweets includes hashtags, thinking also about how they're dealt with and the different ways that they might be processed. As opposed to what the authors describe as the classical method or the C method, which involves removing URLs, the removal of stop words, taking out numbers, doing some standardization, and also removing punctuation. And so this heuristic model, again, I'll just talk a little bit about some of the key steps that are identified. So the decoding, first of all, transforming the text into some machine readable format, which is not something that to be taken lightly, and it depends on the platform that one might use, what might be the outcomes of moving this into a particular format. So the tokenization process, the input text is transformed into unigrams, and for the fact that we've got these tweets, the authors identify that they don't split the hashtags or these emoticons, so they're retained. The numbers aren't removed. The authors identify that they carry some meaning in tweets, so that they should be retained. And then the authors also talk about slang and how it's dealt with, because there's a lot of that. So they talk about, for example, if you've got the word love, and it could be strung out in terms of multiple O's, and that needs to be standardized to its original English form, and that would be a part of the pre-processing. And then what would be retained and not retained, so as I mentioned, the emoticons would be retained, was the decision that the authors made. Okay, and then they had two different approaches to deal with hashtags, and recognizing that really there's some segmentation that needs to happen there. And then they did either try to do some regular expression assessment, and then they had this, something they call this for the Viterbi algorithm that they also applied, and there's some documentation in there. But essentially what they were doing with the hashtags was trying to convert those hashtags into some vector of words that could then be subjected to this similarity analysis. So what they used to compare these two different approaches to pre-processing was their gold standard data set, which was 750 annotated pairs of tweets. And so there was an assessment of these pairs of tweets on a Likert scale to measure the degree of similarity between pairs. So there was information that was done, that was produced, and it ranged from 0, that they were on different topics. 3 was that the semantic meaning was roughly equivalent, but some important information differs or was missing. And then to 5, that 2 tweets were completely equivalent. The pairs mean exactly the same thing. So that was the data set that was used to apply this. And then they used this cosine similarity measure, which I alluded to also in the Kiefer article. And so that was applied to a weighted corpus. And so what essentially we're doing is producing a numerical measure is applied to frequency measures. So if you've got pairs of tweets of T1 and T2, you can get this joint feature vector that contains unigrams. In this particular case is what they were looking at. And then you can produce V1 and V2, or the frequency vectors based on V, and then you can produce this cosine similarity measure. And the mechanics of it are described here. And so the interest was then in producing these cosine similarity measures to these for these short texts. And so there were comparisons then amongst if you just looked at the raw data, then if you looked at data that was pre-processed using this conventional approach, and then if the data were pre-processed using this heuristic method, that was what was of interest. And they talk about using the scikit-learn library in Python to conduct the vectorization. And there was also some weighting of different elements of those tweets. And then they produced measures of correlation and a variety of error measures, including the mean absolute error, the mean squared error, and the root mean squared error. Okay. So here's the results that they produce in terms of what happens when you apply the cosine similarity measure to these pairs of tweets. And you've got the raw data, so you're producing a correlation then between these tweets. And you can look at the degree to which they're identified, the measures of agreement on that Likert scale results in a high correlation based on what you do in terms of pre-processing. So with the heuristic method, so you get a higher correlation, no confidence intervals on this, and then you get what they describe as being lower error associated with this. So the authors conclude that it is important to pre-process unstructured text data, first of all, because if you look at what happens with the raw data, they note that the correlation is lower. So actually doing massaging of the data is an important step. But how you do that when you're looking at these short texts and want to measure similarity, you really need to think carefully about that. So data quality can be improved through pre-processing, and they say that this results in improved performance of their semantic similarity measure. Okay, so we've got more time to do some discussion then. So some of the observations and points that we might discuss around these particular papers. First of all, I think that Kiefer talks about the fact that when we think about quality of unstructured text data, that there really is a lot of opportunity for future research, particularly when we think about a very methodical approach to data quality assessment. When Marcello and I have been looking at the literature on how pre-processing is done, oftentimes it's done in a very ad hoc way, and there's not a lot of description in papers that might be doing analyses of unstructured text data to actually describe what happens in terms of that pre-processing. So the authors of articles that we've looked at might say that they removed stop words, they did this and they did that. But the order in which that happens, what might be used as sources of information, for example, to deal with abbreviations, is not always described with rigor. So a methodological approach, one that really thinks about, as the Alnadran paper does, about what that sequence should look like, may be an opportunity for further research. And I like the Alnadran paper in particular because it actually says, well, what happens if we process things in a different way? Does it influence the results of our analysis? And I think that's a useful question for us to ask as we look forward to increasing volumes of unstructured text data being available, and thinking about trying to produce knowledge from them. And then I like the Kiefer paper because it talks about how these measures of data quality may aid in guiding that pre-processing strategy. So perhaps we need a menu of possible pre-processing strategies to select from. If we know more about different aspects of data quality in a generic sense, much like we do with the MCHP data quality framework, that may help us to identify the dimensions or the features of the text data where quality may in fact be problematic and where we may want to focus in particular on our pre-processing strategy. But of course, there's no standardized set of pre-processing steps that exists. Perhaps that's an opportunity for consensus building in different domains. So thinking about how engineers might approach this, how health scientists might approach this would be good. And I think some discussion about that and potentially some consensus building represents a unique opportunity. In doing so, I think the outcomes of pre-processing will depend in part on the software that is used. And if you look carefully at both of the papers that I've selected for this discussion, they talk very explicitly about the choices that were made in terms of software, and that's a key component. And we don't want pre-processing to really be a black box. It does need to be described with rigor in noting the modules that were used and also what decisions might have been made in the process. And then also, I think it's important to think about how the outcomes of pre-processing will depend in part on the order in which the approaches for pre-processing are applied. So the Alnadran paper lays out that heuristic and has decision trees along the way in terms of what happens next, as opposed to what they describe with their conventional method, where it's just a list of steps that might be done with no recognition or acknowledgement of what order they might be applied in. And we know that's certainly the case when we think about other analyses that we do. If we're doing statistical analyses, for example, what we do to get our data to the point where we want to apply a logistic regression model, we would want to document kind of what happened at which stage. And the same, I think, should apply when we think about pre-processing of unstructured text data. Okay, and then I think the last point that I'd like to make is this issue of the general data quality assessment versus the task-specific data quality assessment. As I mentioned at the outset, the MCHP data quality framework identifies several general purpose measures, and they derive from the fact that we think about data quality as having multiple dimensions. And we can have one or more measures that provide a high-level perspective on data quality and may flag for us where more or less rigor might be needed in the data quality assessment process. And then those concepts or measures can be used to develop strategies to think about, well, how exactly are we going to deal with this? If we've got a lot of outliers, for example, if we see that there's wide variations over time, if we've got temporal data, how exactly we're going to deal with that. And then that allows us to target elements of data quality that might be useful to investigate for specific types of projects. So these are for our individual tasks. Okay. And then finally, I've been thinking a lot about this research. These papers come from non-health domains, and in fact, they don't focus on health data at all, whereas we're really interested in thinking about applications to health data. Marcello and I have been starting to look at clinical notes in electronic medical records. And I think in some ways that they may be similar to short texts, such as what we might find in tweets. There's going to be a lot of shorthand notation. We're likely to have non-standard abbreviations. It's unlikely that there's going to be complete sentences in these data. So the pre-processing that might be done on clinical notes from electronic medical records might be quite different than what would be done in another context. So if we think about these production data, for example, the reasons that Kiefer talked about, looking at reasons for downtime, or in the tree bank data, which is very much focused on complete sentences. It comes from media, so we expect quality to be quite different and the whole structure of the data to be very different. I think there are lots of opportunities to also investigate the factors that may be associated with poor or variable data quality when we look at unstructured text. When we think about clinical notes in the electronic medical records, factors such as looking at physician-specific characteristics, for example, may be important, and that might pose the basis for looking at stratified analyses and understanding how variability exists in the quality of the data. So we shouldn't think about any of the sources that we have, particularly with health data, as being monoliths, but there might be a lot of heterogeneity in that data. Okay, that's it in terms of what I wanted to present this morning. And we've got a little bit of time for discussion.
So I'll jump in quickly, Lisa. That was great. Thank you very much. And I was struck by the flow chart that was presented, and again the tension that I think Doug and Robert both mentioned between sort of having a general approach, but making it very context specific. And because, as you say, a lot of the work is ad hoc, and each data set is unique in its characteristics. So how do you find that balance? Because one size does not fit all for working with complex data. I guess my mind went back to other research designs that have been around for a long time, randomized trials, observational studies, and the attempts to standardize the presentation of the methods, not necessarily the analysis plan. So again, we have Consort, we have Prisma, we have Strobe, we have all of these toolkits or checklists for developing and reporting studies, so that at least it forces the authors to think about all the steps, and hopefully to explicitly describe those in the article. And I know I've pushed JAMA as a leader on this, and I've shown the JAMA checklist for machine learning work. But it just occurred to me that that figure 2 looked almost like those systematic review flowcharts on your search, your inclusion, your exclusion type steps, and whether there is an opportunity to standardize, not the sort of a forcing a common approach, but standardize the reporting along those lines.
I think that's an excellent point, Bill. And you've mentioned guidelines such as Consort. Even in the realm of doing validation studies, now using administrative health data, there are reporting guidelines that are advised. And so I do think as we move increasingly into the realm of working in health with unstructured text data, that this may be a next step to say these are the things that you should talk about, because they absolutely could influence the analysis.
So I'm going to go back. Oh, sorry. Go ahead, Cosine.
Yeah, go ahead, Alan.
Thought Cosine's hand was up, so I wanted to respect that.
Oh, okay, Carson, go ahead.
Okay. First of all, thanks for the presentation. So when we're dealing with the electronic health records, so do you think that the quality of the preprocessing will be better than what is described in those paper? Because in those paper, basically you're dealing with free text from, you're talking about those, whether it is treated tweets or any types of the documents from the web. It is actually it can be actually this on a wide varieties of domain, whereas when you're talking about this electronic health record, it will be for a specific domain. So if we apply those techniques, well, the quality in general will be better because you are more focused. So that is first thing. the second part is in the electronic health record, it is not necessary that the text is unstructured. So have you actually considered about the semi-structured data?
Yeah, Carson, that's a good point. Yeah, Marcel and I have been thinking about that too. Does it truly qualify as unstructured text data? Because there are some components that in fact have structure to it in an electronic medical record. Yeah, and then what kinds of data quality assessments would be applied there? Are they different for semi-structured data than what you would do for unstructured data, for example? So there's a continuum there, as I showed in one of the early slides, thinking about what you do with structured versus semi-structured versus unstructured data. Yeah, and to your second question, or to your first comment around if we're dealing just in the health domain as opposed to, yeah, when you think about what's in tweets, for example, it can cover a whole range of domains. In fact, there could be tweets that are health related, there could be those that are about other topics. And you could parse out those that are just related to the health domain. And would that help in terms of thinking about data quality and also what the references might be? Yeah, it's an excellent point, Carson. Thank you for raising that. Okay, and then on to Alan.
So I need to start off with the admission that I'm totally out of my depth here with a limited understanding. But so the questions I have is there evidence, or what is the evidence that each of those pre-processing things have a direct impact upon the analytic outcome, as opposed to, for instance, the analytic process, computational time and things like that? And I would have thought that, for instance, abbreviations are critical in EMRs because they are they're just all over, they're ubiquitous, and have a huge impact on understanding what you're analyzing. But punctuation, from my perspective, don't understand the relevance of that. So before we're ready to, it seems to me that we're very early in a process of being able to set standards and develop algorithms on how we should go about this in an order that will have an impact on the usefulness of this pre-processing.
Yeah, I think those are all great points, Alan. And I think this area of research is, Kiefer describes it as really being in its infancy, that we jump forward and we do the analysis. So we're interested, as I said, in feature extraction. So from EMRs, there's lots of literature on how you extract different features from EMR data, whether it's a disease, for example, a particular treatment, someone's got a particular medication. We jump ahead to that without thinking about what comes before that. Yeah, and for electronic medical records, for example, a punctuation isn't going to be so relevant as a step in terms of pre-processing. So I think if we're to do more research in this area, part of it is to say what elements of pre-processing are the most relevant, right, and some guidelines around that. So I think it's more a guidelines focus to say what might happen. And I'm excited by that possibility, because I think then it allows us to hold our analysis of unstructured text data to the same kind of standard that we would when we deal with structured data. And we very much want to know in journal articles, how did we deal with missing data? That's a common question that's asked, but we may not be asking it about all of the voluminous literature that's coming out saying, well, we did feature extraction on unstructured text data, and we found 15% of people had a diagnosis of diabetes. Well, how does the method that we use to prepare the data influence that result? Yeah, so I think those are all good points. Okay, Rob, did you have your hand up?
Yeah, one question I was wondering is whether people are keeping track of the effort involved in some of these, because I imagine that pre-processing a bajillion records for very rich kind of notion of quality is a lot harder and takes a lot more time than just going in and removing all the instances of odd punctuation, or something like that. The punctuation question, though, also reminds me of the eats, shoots, and leaves, right? I mean, punctuation can be very important, and that's you know, and which drives me back to, I guess, I feel like, wouldn't it be lovely to have a kind of a almost a matrix of these are sort of data cleaning techniques. These are the kinds of data quality measures. Choose the ones that, you know, optimize the kind of data quality that's most important for you, which means there's another dimension to that table, which is for different sorts of analytic tasks, finding clusters, demonstrating differences, finding correlations, you know, those kinds of different ways that we can, this feels like the palette of kinds of analyses is even richer than in structured data, but that's perhaps partly my lack of familiarity with them. But it is very much a, you know, there's these multiple dimensions to the question. And to me, that raises a horrible specter of, you know, researcher degrees of freedom that could be spent without knowing it. And you end up horribly overfitting the particular problem you've got. And again, looping back to standardizing the reporting being so important, that you know, you have to declare the steps you want to take, the step, you know, prior to starting to do the analysis, because if you're not careful, you choose the steps that optimize your result. And that's I suspect that is when we get to the point where we can worry about all that at once, we're at a very mature stage in this whole field.
Yeah, excellent points, Rob. And I think, yeah, the effort that's involved in this, and how much does it move the needle when we think about the results of an analysis, for example. So if we're producing these, you know, similarity measures, so looking at the similarity between two texts, for example, does a particular step in pre-processing have much impact on that?
Yeah.
And how generalizable is that as well? Yeah. Right, would be a question to ask. Mm-hmm.
Mo wants to speak.
Yeah. Hi, Lisa. Thank you so much for the great presentation. Yeah. Hi. Fantastic. It's really nice to see this. I am struggling with the evaluation measure. Do we really need, like, the improvement from 0.73 to 0.75 is a big deal? I'm really struggling with this, because usually when we process data, as you know, I would even the evaluation measure, like, for example, accuracy, or getting rid of the unnecessary information, or elimination of noise, usually have like a 10% improvement, a 20% improvement. But I'm not sure, do we, from that table, to me, why do we need the pre-processing? Because 0.73 to 0.75 is not really a big deal. And for the same point for the MSE. So I think the evaluation measure needs some kind of a relook or something. I don't know.
Yeah, thanks, Mo. Those are great points, because how much of an impact does it have on the analysis results? And just as we might do with structured data, when we think about missing data, for example, that we might do an analysis without addressing missing data, and then after we do address missing data, and we really view it as a sensitivity analysis, right? To say, are our findings robust to the method that we use to deal with, you know, missing data really is a data quality issue. So in the same vein, perhaps when we think about really guidelines, they are around what happens when we do different things, and can we treat different ways of pre-processing really as a sensitivity analysis. And so I agree with you. When we look at what the similarity between the texts after we go through this structured, rigorous approach for pre-processing, as opposed to if we just use the raw data, I don't think there's a huge amount of difference either. But how do we quantify what is the impact? I think we have to leave that to the reader in part. And by doing sensitivity analysis, it just provides, and we put them in an appendix, for example, or say, you know, report on those in a supplementary table. Just as we do with many machine learning algorithms, we'll try out different aspects of that machine learning. The same could happen with pre-processing. It's a really excellent point that you make. What is the impact, and is it a meaningful impact for all the work that must go into it? Because it's no small task with what's happened in that particular, the Alnadran article, in terms of what work they would have had to do to implement their heuristic pre-processing method. Okay, and with that, we're out of time for today.